SpaceX just revealed a secret cargo vehicle, and almost nobody noticed. While the whole world was watching Blue Origin's explosion, SpaceX quietly dropped a government document. No press release, no announcement, no Elon tweet, just a technical file buried on the FAA website. Inside, a disc-shaped spacecraft, 3.1 meters wide, only 0.7 meters tall, weighing 3.1 tons, built to survive re-entry from orbit and bring cargo back to Earth cheaper than anything ever built before. This isn't Starship. This isn't Dragon. This is something completely different. And it could be worth billions. So why did SpaceX hide it? Here's the thing nobody's talking about. On the same week Blue Origin lit up the sky with its test fire, cameras rolling, headlines blazing, the internet going absolutely wild, SpaceX did something completely different. They said nothing. No press conference, no launch live stream, no dramatic announcement from Elon on social media. Instead, a single technical document appeared on the FAA website, quietly, without fanfare, without warning. It was an environmental assessment, the kind of dry, bureaucratic paperwork that puts most people to sleep in the first paragraph. But buried inside that document was something that should have stopped the entire space industry cold. SpaceX had been secretly developing a brand new spacecraft. Not an upgrade to Falcon 9. Not a new version of Dragon. Something entirely new. Something nobody had publicly confirmed before. They called it Starfall. And the moment researchers and aerospace insiders started reading through the technical specs, the reaction was immediate. This is not what anyone expected. Because Starfall does not look like a spacecraft. It does not look like a capsule. It does not look like anything SpaceX has ever built before. It looks like a hockey puck. A giant, flying, heat-shielded hockey puck, designed to fall from orbit, survive temperatures that would melt steel, and land gently in the Pacific Ocean. And SpaceX believes this simple, strange-looking disk could become one of the most important pieces of infrastructure in the future of the space economy. So the real question is, why did they hide it? What exactly is Starfall, and why does the shape matter so much? Most people think of spacecraft as tall, pointed rockets, or round capsules, or winged shuttles. Starfall is none of those things. According to the FAA environmental assessment, Starfall is 3.1 meters wide, roughly the size of a large dining table, but only 0.7 meters tall. That is about the height of a typical kitchen counter. Put those two numbers together and you get something that looks almost comically flat, like someone took a normal capsule and sat on it. But that shape is not an accident. That shape is the entire point. Here is why it matters. When a spacecraft re-enters the Earth's atmosphere, it faces two brutal problems. First, heat. The friction from slamming into the atmosphere at orbital speeds generates temperatures that can reach over 1,600 degrees Celsius, hot enough to vaporize most materials. Second, control. Once you are falling from orbit, you need to be able to steer, to aim, to hit a specific target hundreds of miles away while traveling at thousands of miles per hour, with the atmosphere battering you from every direction. Traditional capsules, like NASA's Apollo or SpaceX's own Dragon, handle both of these problems with a rounded, cone-shaped design. They are heavy, complex, and expensive. Starfall takes a completely different approach. That wide, flat shape creates something engineers call a low ballistic coefficient. In plain English, it means the disk gets slowed down much more aggressively by the atmosphere compared to its weight. Think of it this way. Drop a coin flat versus edge-on into water. The flat coin slows down almost instantly. The coin on its edge cuts right through. Starfall is designed to fall flat, to use its wide surface area like a brake, to bleed off speed faster, generate less peak heat, and critically, to glide. Because that flat shape also generates lift, not like an airplane, but enough lift combined with small attitude control thrusters to steer Starfall left or right, forward or back, adjusting its landing zone by potentially 300 to 500 kilometers. That is the difference between landing in the middle of the Pacific Ocean and landing precisely in a recovery box that a ship is already waiting in. Simple shape, profound engineering logic. But here is where it gets even more interesting. Because the way Starfall controls itself is unlike anything currently flying. No engines, no fuel, just nitrogen and physics. When most people think about spacecraft maneuvering in space, they think about rocket engines. Powerful thrusters burning exotic fuels, complex systems pressurized with volatile propellants. Starfall has none of that. Its entire attitude control system, every maneuver it makes during re-entry, runs on compressed nitrogen gas stored in carbon fiber tanks totaling just 151 liters. That is roughly the volume of a large household chest freezer. Cold gas thrusters, pure nitrogen, no combustion, no hypergolic fuels that explode on contact with each other, no monopropellants that require careful handling and create environmental concerns, just pressurized gas shooting out of small nozzles to rotate and orient the spacecraft. This is elegant for several reasons. First, safety. Nitrogen is inert. It does not explode. It does not leak toxic fumes. It does not create hazardous waste. For a vehicle designed to splash down in the Pacific Ocean and be recovered by ships, having zero toxic propellants is enormously valuable, both practically and regulatorily. Second, simplicity. Fewer components means fewer failure points. The cold gas system has no turbopumps, no combustion chambers, no ignition systems. It is about as mechanically simple as a pressurized spacecraft control system can possibly be. Third, cost. And this is crucial to understanding what SpaceX is actually building here. Every component that gets removed from a spacecraft is a component that does not need to be manufactured, tested, maintained, certified, and replaced. Starfall is stripped down to the absolute minimum required to do its job. Heat shield, structure, parachutes, nitrogen thrusters, avionics. That is essentially the entire list. This is not an accident. This is a deliberate philosophy. SpaceX is not trying to build the most capable re-entry vehicle. They are trying to build the cheapest, most reliable, most repeatable one. And the trajectory of what Starfall can do, commercially, militarily, industrially, depends entirely on whether that philosophy pays off. So what exactly does SpaceX plan to do with this thing? The two markets that could make Starfall worth billions. Here is something that was stated explicitly in the FAA environmental assessment. Not speculation, not rumor, but official documented intent. SpaceX is targeting two specific markets with Starfall. Market number one, in-space manufacturing. This sounds like science fiction, but it is already happening right now with real companies making real money. Here is the core concept. Certain materials, specific pharmaceuticals, advanced semiconductors, exotic alloys, fiber optic cables with near-perfect optical clarity, can only be produced in the unique conditions of space. Microgravity allows crystals to grow without the distortions caused by Earth's gravity. Vacuum eliminates contamination. The result is products that are physically impossible to manufacture on the ground. A company called Varda Space Industries has already demonstrated this. They flew a small spacecraft, manufactured pharmaceutical compounds in orbit, and brought them back to Earth. The results showed measurable improvements in crystal structure quality compared to ground-manufactured equivalents. The problem? Getting those products back to Earth is expensive, complicated, and slow. That is exactly the gap Starfall is designed to fill. A researcher or pharmaceutical company books payload space on a Starfall unit. Their experiment or manufacturing module rides to orbit as a secondary payload on a Falcon 9. Starfall, attached to a dedicated cruise stage that provides power and maintains attitude, spends days or weeks in orbit while the manufacturing process completes. Then, when the product is ready, the cruise stage performs a de-orbit burn. Starfall separates, re-enters autonomously, and splashes down in the Pacific. A recovery vessel picks it up within hours. The entire operation, from launch to product in hand, could theoretically happen faster, cheaper, and more frequently than any current alternative. And that frequency is the key word, because the real disruption here is not the technology, it is the business model. SpaceX already owns the launch vehicle, Falcon 9. They already have the recovery infrastructure. They already have the operational experience. Adding Starfall to that stack means they own the entire pipeline, from factory floor to orbit and back again. No other company can say that right now. But market number 2 is where things get genuinely controversial and genuinely explosive. The Department of Defense has been publicly pursuing something called the Rocket Cargo Program for several years. The concept is straightforward and simultaneously terrifying in its ambition. Use rockets to deliver military cargo, supplies, equipment, critical components, anywhere on Earth within 90 minutes, not days, not hours, 90 minutes. The challenge has always been execution. How do you actually land a rocket carrying cargo in a conflict zone, or a remote location, or an allied nation that does not have a landing pad designed for whatever vehicle you are using? Starship was discussed as a potential platform, but there are obvious problems. Starship requires significant ground infrastructure to land safely. It is enormous, and as of right now, it does not even have landing legs. It is caught by mechanical arms at the launch tower. Landing a Starship in a field in Eastern Europe or a runway in the Pacific Islands is not a realistic near-term scenario. Starfall is a completely different proposition. It is small. It is simple. It lands on parachutes in water, or potentially on land with minimal infrastructure. It carries 1 ton of cargo. It re-enters autonomously. And critically, it can be deployed from a Falcon 9 or potentially from military rockets that can launch within minutes of an order. The FAA environmental assessment explicitly lists point-to-point cargo delivery as one of Starfall's intended applications. Now here is where it gets geopolitically interesting. The United States military has intercontinental ballistic missiles, ICBMs, that can be launched within minutes. They normally carry nuclear warheads. But the basic technology, a re-entry vehicle on a ballistic trajectory, is exactly what Starfall is. The difference is what is inside. If the military were to deploy Starfall-based cargo delivery using existing missile infrastructure, heavily modified, obviously, you would theoretically have a global rapid cargo delivery system that requires almost no new launch infrastructure. And yes, as the original source material notes, this creates an immediate and serious diplomatic concern. Other nuclear powers, detecting a ballistic re-entry vehicle on radar, would have minutes to decide whether it is a cargo delivery or a nuclear strike. That problem has not been solved, and it is one of the central reasons why this concept has remained theoretical for years. But SpaceX, with Starfall, may be the first company with the technical credibility, the regulatory relationships, and the operational track record to actually bring this concept close to reality. Does that mean Starfall will become a military weapon? No. Does it mean the Pentagon is watching this test program very, very closely? Almost certainly yes. The test mission, how Starfall actually gets to orbit and back. So how does the first real test of Starfall actually work? The FAA environmental assessment gives us the outline, and an FCC experimental license released around the same time filled in several critical blanks. Here is the sequence. Starfall launches as a secondary payload on a Falcon 9 rocket from Cape Canaveral Space Force Station in Florida. It is not the primary mission. It rides along with other payloads, the way a small package might share a delivery truck. Once in orbit, Starfall deploys. It coasts. It checks its systems. The Starlink antennas embedded in its structure, yes, it has Starlink antennas, beam real-time telemetry back to SpaceX engineers on the ground. Every temperature reading, every pressure measurement, every orientation data point. This is important because Starfall has no independent deorbit capability. It cannot fire engines to slow itself down and begin re-entry on its own. It is completely dependent on the Falcon 9 upper stage, or a dedicated cruise stage, to perform the deorbit burn. This is a deliberate design choice, not a limitation. By removing the deorbit propulsion from Starfall itself, SpaceX eliminated an entire category of complexity, cost, and potential failure. But it also means Starfall needs a partner in orbit. It cannot come home alone. For the test mission, the Falcon 9 upper stage performs the deorbit burn, placing Starfall on a trajectory aimed at a recovery zone several hundred miles off the coast of California, well outside the exclusive economic zone in international waters. Then Starfall is on its own. It hits the upper atmosphere traveling at roughly 7 kilometers per second, about 25,000 kilometers per hour. The heat shield on the bottom, a large carbon fiber phenolic structure, takes the full brunt of re-entry heating. The aluminum upper plate stays relatively cool, protected by thermal insulation. The nitrogen thrusters fire in small bursts, keeping the vehicle oriented at the correct angle of attack, between 10 and 18 degrees. This trim angle is critical. Too shallow and Starfall skips off the atmosphere like a stone on water. Too steep, and the heat becomes catastrophic. At that angle, Starfall generates enough lift to steer. It is not dramatic gliding, but 300 to 500 kilometers of cross-range capability means the difference between a controlled landing in the recovery zone and an uncontrolled splashdown miles off target. Once through the plasma phase, the period of peak heating where radio communications are blacked out, the heat shield is jettisoned. Then a pilot parachute deploys. It pulls out a drogue chute. The drogue stabilizes the vehicle and slows it further. Then the main parachute blossoms open and Starfall floats down to the Pacific. A recovery vessel up to 200 feet long is already waiting. Rigid hull boats recover the two vehicle halves. The spacecraft splits into its upper and lower sections after re-entry, along with the parachutes. Everything recoverable gets recovered. Everything that sinks is designed to be environmentally inert, non-toxic, non-hazardous, biodegradable where possible. The first test might involve one Starfall unit. It might involve two. The licensing structure suggests SpaceX wants the flexibility to run multiple tests, though each individual mission may carry only one vehicle. And here is the detail that tells you everything about SpaceX's real ambitions with Starfall. They are not just testing if it survives re-entry, they are testing how precisely it can land. The real competition, and why Varda should be worried. Let's talk about who loses if Starfall works. Varda Space Industries has spent years and hundreds of millions of dollars developing their own in-space manufacturing and re-entry capability. Their W-series spacecraft, built around a Rocket Lab re-entry capsule, has already demonstrated pharmaceutical manufacturing in orbit and successful re-entry. It is genuinely impressive technology. But here is Varda's problem. They do not own the launch vehicle. They do not own the re-entry capsule manufacturer. They are dependent on third-party providers for both, which means they cannot control costs, cannot guarantee launch schedules, and cannot scale independently. SpaceX, with Starfall, owns the entire stack. They launch on Falcon 9, which they build and operate. They recover with their own vessels. And if Starfall becomes a commercial product, they will manufacture, launch, operate, and recover every single unit themselves. This is the same playbook they ran with internet connectivity. Starlink did not just build better satellites. It built the ground stations, the user terminals, the launch vehicles, and the orbital constellation simultaneously. So no competitor could undercut them on any single component. Starfall could be Starlink for atoms. That phrase, originally used in the source material, is actually the most accurate description of what SpaceX appears to be building here. A high-frequency, low-cost, vertically integrated pipeline for moving physical materials between Earth and orbit. And if they succeed, the market implications are significant. Current estimates for the in-space manufacturing market range from several billion dollars annually within the next decade to potentially tens of billions by the mid-2030s, as pharmaceutical and semiconductor applications mature. Right now, that market is wide open. Varda is the closest to commercialization, but they are constrained by cost and scale. SpaceX entering this market with Starfall, especially if they can undercut existing prices while offering higher launch frequency, would not just compete with Varda. It would reset the entire market's pricing expectations overnight. Is that fair? Probably not by conventional business standards. But SpaceX has never played by conventional business standards. And the companies that bet their entire business model on SpaceX staying out of their market have historically learned that lesson at great cost. The twist. What the environmental assessment doesn't tell you. Here is the part of the Starfall story that most coverage missed entirely. The FAA environmental assessment covers the test program. It describes the vehicle. It lists the intended markets. It maps the recovery zone. But it says almost nothing about the cruise stage. And the cruise stage is actually the most important part of the equation. Starfall by itself cannot stay in orbit for long. Without power, solar panels, batteries, thermal control, whatever payload is inside would be useless within hours. For in-space manufacturing to work, the vehicle needs to spend days or weeks in orbit, maintaining precise temperature and orientation, running experiments or manufacturing processes autonomously. That requires a cruise stage, a separate spacecraft that attaches to Starfall, provides power and attitude control during the orbital phase, and then performs the de-orbit burn when the mission is complete. SpaceX has not publicly revealed what this cruise stage looks like. There are no technical documents describing it. There is no FCC license for it yet. But here's the implication that nobody seems to be discussing openly. If SpaceX is serious about Starfall as a commercial product, not just a technology demonstrator, they need to develop and certify a reusable cruise stage simultaneously. A cruise stage that can deploy from Falcon 9, operate in orbit for extended periods, dock or mate with Starfall, de-orbit it precisely, and then either survive re-entry itself or burn up cleanly. That is a significant additional engineering program, one that has not been announced, which raises a question that nobody has a public answer to yet. Is Starfall just an experiment, or is SpaceX already building the cruise stage in secret? The same way they built Starfall itself, quietly, without public announcement, until an FAA document accidentally revealed it. The pattern is consistent with how SpaceX operates. Build first. Announce when ready, or announce when the government forces you to. And if that is the pattern, then what else is already being built in SpaceX's facilities right now that the rest of the world does not know about yet? The bigger picture, Starfall and the emerging space economy. Step back for a moment and look at what SpaceX has built over the last decade. Falcon 9, reusable orbital rockets that cut launch costs by a factor of 10 compared to previous vehicles. Dragon, a crew and cargo capsule that now regularly services the International Space Station. Starlink, a constellation of thousands of satellites providing global internet coverage, already generating billions in revenue annually. Starship, the most powerful rocket ever built, currently in active flight testing, designed to carry humans and massive cargo loads to the Moon and Mars. And now, Starfall. Each of these programs is individually significant, but together, they form something much larger. They form a complete infrastructure stack for operating in space: launch, crew transport, cargo return, communications, heavy lift. The only missing piece, until now, was a cheap, frequent, dedicated return vehicle for physical materials. Starfall fills that gap. And here is the strategic logic that makes this genuinely important beyond just the technology. As more companies build space stations, orbital factories, lunar outposts, and deep space platforms, the need to move physical things between Earth and orbit, in both directions, will grow dramatically. Not just astronauts, not just satellites, but manufactured goods, biological samples, refined materials, specialized components. Right now, the bottleneck is the return trip. Getting to orbit is becoming cheaper. Getting back to Earth, with something valuable and fragile, remains expensive and infrequent. Starfall, if it works as designed, removes that bottleneck. And a company that removes a fundamental bottleneck in an emerging trillion-dollar industry does not just participate in that industry, it controls it. That is what the FAA document quietly revealed. Not just a new spacecraft, not just a new technology demonstrator, a declaration of intent. SpaceX is not just building rockets anymore. They are building the circulatory system of the space economy, the infrastructure through which physical value flows between Earth and orbit. And Starfall may be the moment that system becomes real. The test has not happened yet. The launch license has not been granted. The cruise stage remains unannounced. But the blueprint is now public, hidden in plain sight, in a dry government document that almost nobody read. Almost nobody. Starfall is real. The blueprint is public. The intent is clear. SpaceX did not announce this. The FAA did it for them. If this test succeeds, the return economy of space just changed forever. Drop your thoughts below, like if this opened your eyes. Subscribe to the Space Brief, and hit that end screen for more.